Hi everybody. Today we are going to learn how to find the area above and below the x-axis. We are talking about the x-axis and we need to find a specific area maybe below or above the x-axis. This is a really important concept in calculus because it helps us understand how much space is actually between a curve and the x-axis. So the first thing we will start with is if a function is always positive. Example, if we have a function which is always above the x-axis, for example this function x squared plus 2, okay, the area under the curve is just the area above the x-axis. For example, fx is equal to x squared. So the first thing we have to do, first we find the antiderivative of f squared, okay, between a specific intervals. For example, we will take from 0 to 2. And this is x cubed over 3 between 0 and 2. And as you remember from last time, we said that the integral, you just add 1 here and you divide by whatever is there, okay, and you get the integral. So this is equal to 2 to the power of 3 divided by 3 minus 0 to the power of 3 divided by 3, which gives us 8 over 3. So the area above the x-axis for the function x is equal to x squared. This is x squared between 0 and 2 is 3 over 8. So we just find whatever the area above the x-axis. Okay, now let's us find the area below the x-axis. So sometimes the function is below the x-axis, like the function, for example, this function f of x is equal to minus x. Okay, so as you know, this function is as this. The function is like this. So this is our x-axis and this is our minus x. Okay, and we need to find the area between, for example, 0 and 3. Okay, this area, and as you can see, it is below the x-axis. In this case, the area under the curve gives us a negative value because it is below the x-axis. But as you know, area can't be negative. So we take the absolute value of that. So let's do that. The integral from 0 to 3 of our function minus x dx is equal to, we said plus 1, so minus x to the power of 2 divided by 2 from 0 to 3, which will give us minus 9 over 2 minus 0 over 2, which will give us minus 9 over 2. But as the value is negative, so we take the absolute value of that, which gives us the area is equal to 9 over 2. Okay, so how about the mixed area? Sometimes also a function cross the x-axis, meaning part of the curve is above and the part of the same function is below. So let's, for example, consider this function. F of x is equal to x cubed minus 4x. So if we graph this function, we can see it as this. So there is a part that is above the x-axis and there is a part that is below this axis. So the first thing we should do in this case is find the x-intercept. So we need to find the x-intercept. After that, we can divide our function to some parts. So to do that, we need to set this equal to 0, so we can find where the function, this function, cross the x-axis. So this is equal to 0 means that x times x squared minus 2 squared is equal to 0, and this means that x is equal to 0, or x is equal to 2, or x is equal to minus 2. So we have minus 2, we have 0, and we have 2. Now we need to discuss the area in each section. For example, we will take this area from minus 2 to 0, and this area from 0 to 2, and maybe we can add another area from 2 to 3. Okay, so for x is equal to minus 2 up to x is equal to 0, we can see that our function is above the x-axis, so we don't need to take to do the absolute value. We can just calculate the integral directly. So the integral of x cubed minus 4x dx from minus 2 up to 0 is equal to the integral minus 2 to 0 x3 dx minus 4 integral from minus 2 to 0 of x dx, and this is equal to x4 over 4 from minus 2 to 0 minus 4 times x squared over 2 from minus 2 to 0. As we said many times, you can just add 1 here and divide it by all this. So divided by 4, which we have here. Same thing, add 1 here, divided by whatever you have there. So which is this. The integral is not something difficult to calculate. So this is giving us 0 over 4 to the power of 4 minus 2 to the power of 4 over 4, okay, minus 4 times 0 to 2 divided by 2 minus 2 to 2 divided by 2, and this is equal to what? 16 over 4 minus, because we have a minus here, minus 4 times, this is what? This is minus 4 over 2, and this is equal to what? To minus 4 minus with minus plus 8, which is 4. So the area 1 is equal to 4. We'll just find it here. For the second part, you can see that our function is under the curve, so we need to take the absolute value of our integral. So let's take another color. So for x is equal to 0 up to x is equal to 2, the integral from 0 to 2 of x cubed minus 4x dx is equal to what? Is equal to the integral of, we don't need to go part by part, you can just do it directly because now you know how to do it, is equal to x to the 4 over 4 from 0 to 2 minus 4 times x square over 2 from 0 to 2, which is equal to what? 2 to the power of 4 divided by 4 minus 0 minus 4 times 2 to the power of 2 divided by 2 minus 0. This gives us 16 over 4 minus 4 times 4 over 2 is 2, which is 4 minus 8, which is minus 8, but we need to take the absolute value of that. So area 2 is equal to absolute value of minus 8, which, no, minus 4. The absolute value of minus 4, which is 4. So now we find the area number 2. Now let's find the area number 3. We see our function is above the x-axis, so we don't need to take the absolute value. We just apply the integral directly. So for x is equal to 2 up, x is equal to 3, the integral from 2 to 3 of x cubed minus 4x dx is equal to x4 divided by 4 from 2 to 3 minus 4 times x squared over 2 from 2 to 3, which is equal to 3 to the power of 4 divided by 4 minus 18, this minus 16 over 4 minus 8, which give us 81 over 4 minus 72 over 4 minus 16 over 4 minus 32 over 4, which give us 9 over 4 minus is plus 16 over 4, which give us 25 over 4, which may be equal to approximately 6.25. So the area, the general area now is, this is area 3. So our general area is the sum of areas. So area is equal to area 1 plus area 2 plus area 3, which is 4 plus 4 plus 625, which is into 125.